Okay, hello. This is section 4.3, division of polynomials. Okay, so we are dividing the polynomial in this sections. Okay, so polynomial by monomial first. Okay, so which means your dividend is a polynomial, but divisor is the monomial. So in order to this case, it's different from the divide by binomial or higher degree. So on this case, you just need to put that as a fraction form. So x fourth plus 8x squared minus 5x over 4x squared. And then split them out, each of the numerator to denominator. That's easier to write it as answer. Answer look weird though. Okay, so once you get that, and then simplify possible. So square cancel 4, 2. So you have x squared over 4. And 4 goes 8 twice, and x squared cancel, which is 2 over 1, same as a 2 minus. And then 1x cancel, 1 cancel, so you still have a 1 factor of the x in here, so 5 over 4x. So that's all. Okay. But when you have a divide by polynomial, in this case, we can use the division algorithm for the polynomial. So division of the polynomial is gonna be same as a f of x equal to d of x, which match to the divisor. Q of x is a quotient. R of x same as a remainder. So same as you learned your division using long division in the 4th grade. Alright, so dividing a polynomial by long division. So in order to do that, we have to use this, which is 3x cubed minus 3x squared minus 2x minus 4 divided by x minus 2. So what you need to do is, as a long divisions, you need to divide the 3x cubed divided by x. Okay, so in order to do that, you put the 3x cubed, pull it out, and divide by x, which means you got 3x squared. So this is the quotient. So quotient is always on the top of the line. So I put the 3x squared here. So once you find the 3x squared, now you need to multiply 3x squared to the x minus 2. So you need to multiply that with the x minus 2. And then your product distribution, you got 3x cubed minus 6x. So you got 3x cubed minus 6x. And then what you need to do is you need to subtract the 3x cubed from the 3x cubed, and you need to subtract negative 6x to the 3x. Oh, it's a square. Sorry, yeah, it's missing. So it's a square. What am I talking about? Okay, so you have to subtract. You have to subtract the negative 6x squared from the 3x squared. So which means easier way to do this problem is change the sign. Change the sign of the what your product is, and then combine. The combine means the first term always need to be canceled. So second one, instead of the 9x squared as a negative, you got the 3x squared, and then bring down the negative 2x. And then divide again. Now I divided it from the 3x squared to the x. So you divided 3x squared over x, you got 3x. So that is a quotient, so now you're going to put it up here. So plus 3x. Now you multiply with the 3x to the x minus 2. So you multiply. So you multiply 3x to the x minus 2 distributed. You got 3x squared minus 6x. So you got you get 3x squared minus 6x. But this time I said you need to subtract. So subtract means a change of sign of the product you just put. So cancels out. Now you got another 3x and then down the negative 4. And divide again because you still have a 3x because this 3x is a degree of 1 and this x is a degree of 1 too. So when you have the same degree, you still need to divide it. So divide means you got 3x divided by x, which is a 3. So I put 3 here. Oh, sorry. I made a mistake here. Sorry. It's me 4x, right? What am I talking about? So 4x minus 4. So when you divide that, okay, so this becomes a 4. X actually they'll come out as a 4. Okay, so we have now we have a 4 to use. So now we're going to multiply this 4 to the x minus 2. So you got 4 times x minus 2. Distribute, you got 4x minus 8. So become negative 4x minus 8. Subtract means you got to change the sign of the product and becomes a 4. So 4 is actually the remainder. So 3x squared plus 3x plus 4 is a quotient, divisor, and remainder. And this is a dividend. Okay. So if you multiply quotient to the divisor, add it to the 4, the product must be equal to this one. Okay. All right. So add that, and then the answer is going to be plus 4 over x minus 2. So this is the answer for the long divisions. Okay. Then we'll practice more from the next problems. So in the next problem, okay, now I have 4x squared plus 2x plus 1. So in here, I do the 4x squared plus 2x plus 1 and divide by 2x minus 1. So same thing. You do divide 4x squared to 2x, which means 4x squared divided by 2x, and reduce, I got 2x. So I put the 2x over here. And then I multiply the 2x to the 2x minus 1. So which means I multiply 2x to the 2x minus 1. I get the 4x squared minus 2x. So I got 4x squared minus 2x. And then I need to subtract. So subtract means we'll change the sign. And then you combine, so cancel. Now I got another 4x plus 1. So divide again. 4x divided by 2x, which is a 2. So plus 2 here. And then multiply 2 to the 2x minus 1. I got 4x minus 2. So 4x minus 2. Now I have to subtract, which is a remainder is a 3. Okay. So you need to write the answer as 2x plus 2, which plus 3 over 2x minus 1. That's all. That's the answers. And also the next problem, same thing, but when you have a long division, okay, you have to put the degree in the descending power. But when you put the descending power, you have to find out that if there's any the missing terms. So I don't see here as x, which is I just gonna put the 0x. So because when you have a degree of 3, the degree of 3 is starting from the 3, 2, 1, and the last one should be a 0. So when you have a degree of 3, you're supposed to have a 4 terms. But we only have a 3, which is the x terms are missing. So I'm going to write it all, okay? So when you write it, I get 3x to the cube minus 2x squared plus 0x plus 4. And then divide by x squared plus 2. Especially example 3, we have to use a long division, okay? Because x squared plus 2, we cannot put that as a linear. And then we did the division, okay? So how do you divide it? You got 3x cubed and divide by x squared. I got the 3x. So 3x above the 0x. So the reason that I put the 0x because of we need the placeholder. Yeah, because if you don't have a 0x, you don't know where you're going to put the 3x as a quotient place, okay? And also the product too. Now I'm going to multiply the 3x to the x squared plus 2. And then multiply, you got 3x cubed. And then it's going to be plus 6x. Now I need to subtract. Subtract. Change the sign. And then this cancel. I got dropped. I haven't used a negative 2x squared, right? Minus 6x. But this time, actually, you need the 3 terms. Because x squared plus 2 means there are 3 terms. And then divide again. So I divided negative 2x squared to the x squared. Now I have a negative 2. And then multiply. From the negative 2 to the x squared plus 2, I'm getting negative 2x squared and minus 4. And then I need to subtract, which is a change of sign. And this cancel, negative 6x plus 8. But this time we are done because the divisor has a square and the remainder has a degree of 1, which means, yeah, you can not divide the lower degree from the larger degree. Okay, so we are done. So your answer is going to be 3x minus 2 and plus negative 6x plus 8 over x squared plus 2. So this is how you write it. All right, there's another way we can do as a polynomial division. It's going to be a synthetic division. So synthetic division means we always need to be the x minus k is a linear. Has to be the linear factor can divide it, okay? In this case, we only use a k, okay? But k's already come with a k, negative. So you have to watch out the sign, okay? So let's look it up, this problem. So yeah, this is actually the explanation that I put above. I'm talking about this, okay? So yeah, you can read it out if you want it, okay? If you're confused, okay? But I want to show you as an example. So use a synthetic division to divide 2x cubed minus 4x squared minus 1. So first of all, same as a long division, you need to find the missing terms. So there's a cube, square. So I know that there's x terms are missing. All right, and then which means if you rewrite fully, you should have a 2x cubed minus 4x squared plus minus, it doesn't matter, x minus 1. But we are only using the coefficients. It says here, we are only using a coefficients. The coefficients are 2, -4, 0, and 1. -1. You don't have to put the comma, but I want to have some little space. But this is important, okay? The number that you're going to put it in here is important. It's from here, here. But the thing is, you need to know that x plus 1 is the same as x minus of -1, right? Because k's always come with a negative, okay? So your k this time is -1. It's going to be -1. And then I need to put the bar, leave some space that we're going to fill it in, okay? So first number 2, just drop it. Because there's nothing between that. So drop it. Now we're going to start multiplying. So we're going to multiply -1 to 2. We're going to multiply -1 to 2. And then the product is -2. So you put the product here. So product. The product always number on the bottom number to the always number from this number to this number. And then you'll get this number as a product. And then once you do the product, and then you need to add it. You need to combine this. So -4 plus -2 becomes -6. And then multiply again. So this place is we call the sum. And then you multiply -1 to -6, which is a positive 6. And then add them again. And then you got 6. You got 6. And then multiply again 6 and -1. You get -6. And then combine with a -1 plus -6 become -7. And then you're done. And also when you use a synthetics are always divisible by the linear. So the quotient always 1 degree less than the problem. So degree was 3, right? Because this was x cubed, right? It's cubed, which means this is always 1 less than the 3, which is a 2. And then just write down as -6x plus 6. And then the last number is always a remainder. So what you do is plus over, you can get x plus 1. So that's all. So which means if you use a synthetic, we skipped all this, all process, okay? We only get the quotient and the remainder right away. All right, so let's do more practice. So in example 4, the area of the rectangle is 2x squared plus 7x plus 3. And its width is x plus 3. Use the division to find its length. Okay, so in here, I want to talk about the area of the rectangle, which is the length and width. But we are looking for the length, okay? So for L, which is divided by width, which is the length is area divided by width, which is area is 2x squared plus 7x plus 3 over x plus 3. So in order to find the length, of course, you can do the long division, but I like to use a synthetic. Okay, so in synthetic, 2x squared plus 7x plus, there's no missing terms. So I put 2, 7, 3, and then divide by, I'm not using 3. I'm using -3. You know why, right? Because x plus 3 is the same as x minus of -3. So I'm using the negative number. And then what I do is drop the 2. And then multiply negative 3 and 2, which is negative 6. Combine them. 7 minus 6, which is 1. Multiply again. Negative 3 to 1, which is a negative 3. And then this time the remainder is a 0. So this is a remainder. So when you have a remainder, you don't have to care. So which is about, this was a x squared, but this becomes a x plus 1. So this is it. This is a width. Because you are so, oh, sorry. This is a length. We already have a width, right? So this is a length. All right. And then we also have a remainder theorem, which means that we don't care about any quotient, but we only care about the remainder we have here. So what you do is, whatever k you have, right, you just plug it in to find it too. So let's see if we can get the remainder for this one. So what I do is, let's set that up as a function from the example 4. So your function is 2x squared plus 7x plus 3. And then I'm using the negative 3 to plug it in. But I know there's going to be a 0 because we already used the synthetic to find the remainder. So this is a remainder. This is what we're looking for. So 2 times a negative 3 squared plus 7 times negative 3 plus 3. So 2 times 9 minus 21 plus 3. 18 minus 18. Yes, don't you see? It's a 0, right? So yeah. So we know that this is a remainder, okay? So you can just plug it in to find the remainder too. All right. Thank you for listening.